We will do arrays today, and we'll take up insertion in an array. Now when we talk about insertion in an array, insertion can be done in two types of arrays. So one is an unsorted array, right, and the other one is a sorted array. Now we all know that unsorted array, when the insertion is to be done, it can be inserted at the end, right? So there's no problem in this. You just have to go to the end of the array and insert the element there. But in the case of a sorted array, whether it is sorted in ascending or descending order, we have to find the correct location, exact location where the element has to be inserted, right? So inserting in a sorted array is what we will be doing, right? Now supposing I have an array like this. Here I am making an array, right? And let's say it is a sorted array, so we'll have the elements inside this. Let me say 4, 6, 8, 11, 21, 34, and these two spaces are empty, right? Now the question is 34. Insert an element. Insert an element whose value is, let's say, 15. Now when we look at this array, we know that 15 is to come in this position. 15 is to come after 11, right? Okay, so I'll put it like this. 15 will come after 11. So now what happens is, see, when I have to put 15 here, this is the place where 15 has to be put. So if I put 15 here, then this 21 and 34, they have to be shifted like this. This will go here and this has to go here. Only then this space will become empty. Understood? So this 21 should come here, right? And this 34 should come here. So now what happens? This space is free now, and when this space is free, I can put this 15 here. So basically we have to locate the correct exact location where the new element has to be inserted, and the second thing is the already existing elements, the already existing values or elements, right, have to be pushed so as to make space for the new element, right? These are the two things that has to be done. And supposing the array is already full, in that case insertion cannot happen, right? If the array is full, then no insertion can take place, right? Now we will see how to do this using the program. Now I'll write the program for this, and let's try to understand what is happening in the program. Okay, now I give the prototype of the function. We call it as int find pos, right? Now inside this find pos, I have to give the array, right, integer array, and we have to give the size of the array and the element that you are trying to insert, right? This is the prototype. Now I come to the main function. Here now first of all you take an array, you give the maximum size for the array, let's say the size is 50, right? And then we take int item n and index, right? Now you ask the user how many elements do you want in the array, right? Whatever the user enters, that is to be taken in the element variable n, right? Okay, now after that enter the array elements. Now entering the array elements is a simple for loop. So here I say for int I is equal to 0, the size is now n, so I less than n and I plus plus, right? See in the array name is array, so here I have I, fine, that's it. Now after that we are going to use this, do this with a loop, right? So as long as the user wants, he can input the values, right? So char ch is equal to y we take, and now here I put a while loop. I say ch is equal to y, or ch is equal to capital Y, like this, right? Now after this I'll come to the next page. Now here cout, first of all enter the element to be inserted, right? Now whatever the user wants to insert, that is taken in this variable item, right? Now first of all I check what is the size of the array. The size of the array is already equal to its full, array we had taken, the maximum size of the array is 50, right? So now I check what is the size of the array, what is n, right? Has n reached 50? If n is already equal to 50, that means there is no space in the array, so now you can't insert anything. So you write array full, right? No element can be inserted, something like this, right? And then you can exit. If the array, the size of the array is not 50, in that case now I'm going to call the find pos function. Index is equal to find pos. Here I pass the array, right? The size of the array and the item that is to be inserted. Okay, now I'm going to write that function. Its return type is int, right? Find pos int array, fine, comma int n, comma int item, something like this. Here I take a variable int pos, and now see, let's take an array here so that you can understand it properly. Like this. Now I put some values inside this, 4, 5, 8, let's say 12 and 15 and 17, like this, right? Okay, now it comes to this int pos. After that int pos, now supposing I say the value to be inserted, right? Value to be inserted is 14. Okay, fine. Okay, now here see, now I do if item, what is item? Item is 14, right? If item is less than array 0, if item is less than array 0, in that case we say position pos is equal to 0, right? Okay, because supposing I want to insert the element 2, right? Instead of this 14, if I want to insert 2, then what will happen? If I want to insert 2, 2 has to come before 4 actually. Is that right? So that means the position of that item should be 0. So in that case, we are returning this pos is equal to 0, right? Okay. Now, if item is less than array 0, it's not, right? In our case, we said we want to put 14, right? So let's go with that. Else, now again I have a for loop here. For int I is equal to 0, I less than n minus 1, right? And then I plus plus, fine. Okay, now you search for the position here. You say if array I is less than or equal to item and item is less than or less than array I plus 1. This is the condition. Okay. Now let's see this. Now our item was 14. So now I start from 0. If array 0, that is 4, is less than or equal to 14. Now I'm going to write it here. 4 is less than or equal to 14. And the second condition is 14 is less than 5. Now the first condition is true, the second condition is false. That there is a and in between, right? Okay, so that means both the condition have to be true. This is 5, right? Okay. Okay, so this condition is not true, so it goes to the next element. Now what happens? Now it checks 5 is less than or equal to 14, right? And 14 is less than 8. Now this is also not right. Now it comes to 8. 8 is less than or equal to 14 and 14 is less than 12. This is also wrong, right? Now the next one, 12 is less than or equal to 14 and 14 is less than 15. Now I have got the correct condition here. 12 is less than or equal to 14 and 14 less than 15. This is true, right? Both the conditions are true. So now when I come to this place, see, I started from 0, right? Here the value of I was what? Here the value of I was 0. Here it was 1, here it was 2 and here it was 3. Okay. So now when I come into this condition, the value of I is what? The value of I is 3. Now I say pos is equal to I plus 1. So what happens? Pos becomes equal to 4, right? Sorry. Pos is equal to I plus 1. Pos becomes equal to 4. And then we break. Once I get that particular location, there is no need to search further. I have got that position, I break from here, right? Okay. Close the for loop. Close the for loop, right? When you come out of the for loop, you check what is n. If n is equal to size minus 1. If n is equal to size minus 1, then you should write pos is equal to size, because this is for, supposing I want to insert the value, I'll just change this. Supposing I want to insert the value 21. If I want to insert the value 21, right, I've put 21 here, this one. If I want to insert the value 21, in that case it will check all of them, but it will never get a correct position because we have the values only up to 17. So 21 has to be inserted, 21 has to be inserted in this place, right? So now when it comes out, we have to check if n is equal to size minus 1, then in that case pos is equal to size. So that will be inserted at the last position, right? So here you close the else, this is for the else, and after that here you say return pos and then close the method. Fine. Return pos. Now this position is being returned into this index. Okay. Okay. Now after that, here you say for I is equal to n, right? I greater than index I minus minus. I is equal to the size. Okay. I should be greater than the position that is returned, in the index, and I minus minus. Now I am going to push the elements. Here I say array I is equal to array I minus 1, right? This is for shifting the elements. Shift elements so that room is created for the new one, right? Now after that, array index is the position, right? Okay, array index is equal to the new item that you want to insert. Now the item is inserted, right? And once the item is inserted, the size of the array becomes greater by 1. So n is equal to n plus 1, that you have to do, right? And now you ask cout, want to insert more elements. If the user says yes, the loop will continue, right? Yeah, endl, right? Cin, this is your choice, right? This is the loop, the while loop that we had, right? And after that, if you want to show the array can be displayed by giving a simple for loop. Otherwise, just put a return statement and close the main function. If after this point, if you want to display the contents of the array, right? The user is asked, want to insert more elements. The user says yes. He can go back to the loop, right? This is the end of your while loop. End of while loop. So if the user says no, he will come out of the while loop. After coming out of the while loop, you can show the array. The array is something like this, right? And then you put this for int j is equal to 0, j less than n, j plus plus. Now when you say j less than n, the size of n is already incremented by 1, right? And the new element is also there. So here you just have to say cout array j, fine. After that I give a space like this, so that no need for an endl because it will come on the same line, fine. And after you come out of this, you can give an endl if you want, and then you say return and then end the main function like this, right? So basically here what you have to understand is the find pos position that we have done here, and after that this is the place, this is the place where the room is created for the array. I start with I is equal to n, supposing n is 10. So for I is equal to 10 and I greater than, that is 10 greater than, suppose I want to put it in element number 7. So 10 greater than 7. Now array I is equal to array I minus 1. That is array, this is 10, the maximum size of the array, right? Okay. array 10 is equal to array 9, array 9 is equal to array 8. Like that the elements will get shifted. But the thing is, there should be room for the elements to be shifted to the right. To the right also there should be space here. If there is no space, then first of all it will come to this, if n is equal to 50 thing, and it will exit, right? So that is how we insert elements into the array. This is insertion of elements into a sorted array. Unsorted array is a normal insertion which is simple, nothing is to be done there. So for insertion into a sorted array, this is the program. So with that I come to the end of this session. Bye.